This is Mr. Beck Does Your Homework, AP Physics, Homework 9.4, question number 1. An electron moves at 3.4 times 10 to the 6th meters per second. That's my velocity, is 3.4 times 10 to the 6th meters per second. Into a uniform electric field. Uniform electric field means I'm not going to use my point charge equations, of magnitude 1519 newtons per coulomb. So that is my electric field strength, is 1519 newtons per coulomb. The field is parallel to the electron's velocity and acts to decelerate the electron. So if I'm thinking about this field, let me just draw the field for a second. What if I draw the field to the right? Well, a field to the right would take a positive charge and send it to the right because that's the direction the field points. So if my electron is flying to the right, it's going to have a force on it to the left. So that's what I'm looking at. That will act to decelerate the electron. So the electron's velocity is going to be this way, but the force on the electron is going to be that way. How far does the electron travel before it is brought to rest? Well, I'm looking for a displacement of the electron before it is brought to rest. So I have an initial velocity of 3.4 times 10 to the 6th. I know that my final velocity is going to be 0 meters per second. I know the electric field. What I'm looking for is the force. Well, the force on the electron is going to be the amount of charge times the electric field. I know the charge on the electron is going to be 1.6 times 10 to the minus 19th coulombs. I'm just going to do the magnitude times my electric field of 1519, and that'll give me the force on the electron. Well, if I want the acceleration of the electron, it's going to be F over m. So I could do this with the acceleration of the electron, F over m, where the mass of the electron is 9.109 times 10 to the minus 31 kilograms. So I could figure out the acceleration of the electron. I have an initial velocity, a final velocity. I'm looking for a distance. So I'm looking for the equation without a time in it. So I know that v squared equals v0 squared plus 2ax. That will solve for my distance the electron travels. Watching out for positives and negatives, but they're squared, so that's fine. The other way to do that would be to think about conservation of energy. I could do conservation of energy where the electron is moving with some kinetic energy, and then it's going to gain some electric potential energy as it moves into the field and comes to rest. So my kinetic energy beforehand is going to equal my electric potential energy afterwards. Well, my electron's kinetic energy is going to be 1/2 mv squared. My electron's potential energy is going to be where that charge is in the based upon the voltage. So what that is going to be QV. So my electric field, in terms of voltage and distance, I know that since the electric field is volts per meter, it's my voltage divided by my distance traveled. That D is what I'm looking for. It's actually the X, my displacement here. So if I want my to plug in for V, I know that V equals ED. So that means that 1/2 mv squared is going to equal QED. And you're solving for D or X here, so X is going to equal D if we want to call it that. So equivalent, it's going to be equivalent, but I've got my mass, my velocity squared. There's also a v squared. QED is what I'm getting there because v squared is 0. So this is actually going to turn into the same equation, but this is the way to think about it energy-wise, because this charge in the electric field moving a certain distance will gain some electric potential energy as it loses its kinetic energy. But either way, we're dealing with conservation of energy or motion equations of motion.